Hi everyone, so today I'm going to be talking about the definition for velocity and definition for acceleration and the differences between them, because this is one of those conceptual problems that most of the time students are having. Basically understanding what acceleration is and what it is, the differences between acceleration and velocity. All right, in the previous video we talked about velocity and we said, well, velocity, the definition for velocity is change in displacement over the time. So we know that displacement is a vector quantity, so is the velocity. Since these are vector quantities, their direction matters. So conventionally we use the set of coordinates whose positive directions are upward and to the right or eastward. And please note that this is not set in stone. You are more than welcome to use your own set of coordinates as long as you're consistent with your calculations in terms of your coordinates and the directions of velocities and displacement within your set of coordinates. You're good to go, and you have to get the same answer compared to someone who's using some other set of coordinates. All right, so basically velocity is change in displacement. So if you go from this position to this position and you go to the right, and we choose right to be positive, this becomes positive. Time is always positive, and velocity gives you a positive answer, and that means you're basically moving to the right. Again, since we chose the right to be positive, your answer is going to be positive. All right, now this velocity can change. Obviously, velocity is a dynamic parameter. It can change from one point to the other. Everyday life experience, you know that, when you get into your car, you start the car, start from rest, then speedometer goes up, then you see a stop sign, speedometer starts moving, moving down, and you slow down, sort of. So basically, this velocity is a very dynamic parameter. It changes at all times. So it's suggestive that, it's a good idea to define a parameter that deals with the change of this dynamic quantity, and that is called acceleration. So acceleration is essentially the change in velocity over time. Since velocity is a vector, the change in velocity is also a vector, and acceleration hence becomes a vector. Please note that the direction of acceleration has nothing to do with the direction of velocity per se. The direction of velocity can be anywhere, and then the direction of acceleration can be totally different. So this could be positive, and the direction of velocity could be positive. However, the change in velocity could be negative, which results to acceleration being negative. I'm going to explain all of these in really full detail. So really nothing to worry about at this point, but we'll go from there. So just know that acceleration is not velocity over time. It is actually change in velocity over time. So that's one of the things that you guys are making a mistake on. You think that if velocity is zero, acceleration has to be zero. No, velocity by itself, if it's zero, you have to take a look at an instant before that and an instant after that. If the velocity is like zero for like some duration of time, then sure, acceleration is going to be zero. But it could be that instantaneous. Let's say I drop something up in the air, it stops momentarily and it comes back down. The velocity at the highest point when things are dropped up, and then here the velocity is zero, the velocity at one instant before that and an instant after that is definitely non-zero. So we can't say because velocity is zero, acceleration is also zero. Of course not. Velocity itself doesn't come into your equation. It's the change in velocity. And basically, if you want to feel acceleration on daily, everyday life experience, you can just think about when you push either your gas pedal or a brake pedal. So either way, you're changing the speedometer on your car, and then you're changing the velocity number, and then you're going to be having one particular delta V. Hence, it gives you an answer for acceleration. Obviously, the harder you push, less time you're basically the faster this velocity is going to get changed, and basically the higher acceleration is going to be. So this is the definition of acceleration. Like I said, it's not velocity per time, it's change in velocity per time. Velocity's units in SI system is meters per second, hence acceleration's unit is going to be meters per second, which gives us meters per second squared. So that's that. Now let's just figure out, well, so how would I relate the direction of change, the direction of velocity with the acceleration, and how basically we could deduce from velocity the direction of velocity, the direction of acceleration, and vice versa. For this, what I'm trying to do now is basically I'm giving you 4 different options in general on how things can possibly move. All right, so let's get that. Let's just get started with that. So suppose we live in a world where our convention for positive is to the right, and suppose there is a car who's moving to the right. So velocity here is positive, but it's moving by, like, let's say 20 meters per second, and then 1 second after that, the velocity becomes 30 meters per second, right? So as we know, this second velocity is greater than the third one. So because there is a change in velocity, I'm going to be having an acceleration. Acceleration is going to be 30 minus 20, 10 over 1 second, and that gives me 10 meters per second squared. All right, so that's that. All right. And as we see, everything is now positive. It just turns out to be positive. I drop, as you figured, as you realize, I drop the vector signs just because everything is along one direction, so it really doesn't matter. It's not diagonal, that it has both x and y components, so we're safe to just drop the sign. So on the other hand, I can have a motion that I have a velocity of, let's say, 20 meters per second to the left. So on our convention, this is going to be denoted by a negative sign, and this is going to be my v1. Then a second later, my velocity v2, it's going to be increased by by 30 meters per second. So still it's in the left direction, so it's going to be negative as well. So acceleration is v2 minus 20 over 1 second. And that's going to be minus 10 meters per second squared. As you see, now everything is negative. So velocities are negative. They're both moving towards the left, and the acceleration turns out to be a negative sign. All right. So far we're going to be having these 2 scenarios. Now let's move ahead and let's move on, and let's just do 2 other scenarios where we're going to be having different signs for velocities and accelerations respectively. All right. So for the third option, let me just use another color here. So I'm moving to the right. So I'm moving to the right by 20 meters per second. But then I'm gonna then I see probably like there's a lot of traffic ahead of me, so I'm gonna be decreasing my speed, and then a second later my 20 meters per second is gonna be decreased to 10 meters per second. All right, so if you do the math, the acceleration in this case, it's gonna be 10 minus 20, so minus 10 over 1, and that gives me minus 10 meters per second squared. So here in this, in this example, I have minus 10 meters per second squared, and as you see, my velocities, although both of them were positive, my acceleration turns out to be negative. So that's already a lesson learned. Do not associate the signs of velocity with the sign of the acceleration. There is nothing. There is no particular relation between velocity per se and acceleration. Acceleration is change in velocity, not velocity vectors themselves. The fourth possible option would be me going to the left. So now I'm going to be going with minus 20 meters per second, but now towards west. Let's say I-10 west, if you live in the States, you're going towards west, so it's negative because we define positive to be our eastward, and then there is traffic on I-10, so I'm going to be decreasing my speed, and then I'm going to be going by now on my speedometer minus 10 meters per second. So having said so, if I want to figure out the acceleration turns out to be, in this case, acceleration is going to be minus 10 minus 20 over 1 second. So as you see, acceleration is going to be minus 10 plus 20, and that's going to be 10 meters per second squared. So as you see, although I had both velocities as negative, my acceleration turned out to be completely positive. So now let's just figure out what's the trend between these four scenarios. In one scenario I have all of them positive, in one scenario I had all of them negative, in one scenario the velocities were positive, acceleration was negative, and that's the very last one, the velocities were negative but the acceleration turned out to be positive. If you think about everyday life, like basically life experience with this, and if you think about it as basically common sense wise, in this case you were speeding up. So speeding up. In this case you were also speeding up because on your speedometer you went from 20 to 30 towards I-10 east. Here it was 20 to 30 on your speedometer, but it was I-10 west. Nonetheless, you're speeding up. All right. Now the last two scenarios where you're having positive negatives and negatives positive, then what you had essentially was that you were slowing down. There was like traffic right in front of you, so you were going by 20, then you slowed down, and then you basically, the speedometer came down to 10 meters per second. And then here, your velocity basically went down from 20 to 10, although you were going towards I-10 west. So the east and west, essentially the signs of the velocity really doesn't matter. It's the change in velocity that gives you the acceleration. So here you're slowing down. Here is also you're slowing down. All right. Now, let's look for a trend. If you think about these four scenarios, you'll see whenever the signs of velocity and accelerations are the same sign, I don't care if it's positive or negative. Nature doesn't care about it, because positive and negative for us, it's just a convention for us to do some math. It's regardless of what nature does. Whenever you're having the same sign for velocity and acceleration, I don't care if it's positive or negative, then the same sign for both gives me speeding up situation, and whenever the signs for acceleration and velocities are the other way around, then you always are having slowing down situation. It's as if you're moving somewhere but you're dragged by something else. Later on in the next videos, you'll see that direction of acceleration, whether it's positive or negative, the direction of acceleration shows you the direction of the force that's exerted on the object. However, the direction of motion is the direction of velocity. So if you're moving towards the right and then you set your right to be positive, then that positive is for the velocity, has nothing to do with the acceleration. For acceleration, you have to look and see how that positive velocity changed. Is it slowing down? Is it growing? What's happening to it? And then that's going to be your acceleration. So I hope this sort of, clears up all the dilemmas and everything, and all this problems that I very frequently, unfortunately, see that students are having. I make this video. Please share with whoever you care, and please please subscribe to see more videos of this kind. Please comment so that I know what type of videos you like to be made. I'm a physicist, so you ask me the question, I'm here to answer, and I do my best to basically have them up in a timely manner. Take care, you all. I'll see you on the next video, and I'm going to be talking about this force and acceleration and a lot of problems with forces and acceleration and velocities and whatnot. All right, take care. Bye-bye.